All right, one last equation to talk about here. So we have Janice. She's going to try to save money for college. She wants to save up $40,000 for college, and she has 8 years to do it. She has $1,000 in her savings right now. What we want to figure out is what is her rate? What is her multiplier that she'll need to have in order to help her reach her goal? So we're going to obviously write this as an exponential function because we're multiplying by something each year. We're multiplying by our interest rate. So if y represents the amount of money and x represents the number of years after today, let's find an equation that models Janice's financial situation. So we want, we're going to need to figure out, how to find the rate. So in order to do this, let's talk about what we know. Let's talk about this is year 0, okay? And she has $1,000. And by year 8, she would like to have $40,000. Okay, so we can set up an equation, right, or a system of equations. And again, I'm going to write this one on top. So I would have 40,000 equals AB to the 8th power. And then I'm going to write this one next. I would have 100, that should be 1,000, not 100, equals AB to the 0. And then solve that system of equations. What's really nice is since I chose now to be year 0, this just becomes 1,000 equals A. And then we don't even have to worry about dividing the two equations because now I know what A is. So knowing A, I'm going to plug in A into my equation above. So 40,000 equals 1,000 times B to the 8th power. So if I divide both sides by 1,000, I get 40 equals B to the 8th power. And then I'll have to figure out what the 8th root of 40 is. About, let's say 1.5858. So that's our B. Now, if you remember back when you were doing problems like this in Algebra 1, that represents an interest rate. So if B is our rate of growth, right, and that is 1.5858, I've got to figure out what percentage of interest is she actually earning. So it's something either more than 1 or less than 1. What I do is I take 1.5858 and I multiply it by 100. And that gives me 158.58. This is a percentage. I need to look at how much is that over 100 or under 100. So an easy way to figure this out is just to take your percentage and subtract 100. And we get 58.58%. So her interest rate would need to be 58.58%. Okay, so we're going to take a look at and compare what Janice's situation is to Sarah, Janice's friend. So Sarah is starting with $7,800 and wants to have $18,400 20 years from now. We need to figure out what her interest rate would be. So we're going to repeat this process and find Janice's friend's interest rate and then determine which one is more realistic from there. So pause the video, try it out, and you can come back and check your answer when you're finished. All right, so I have work shown for you. Sarah ends up with an interest rate that she needs to have is 4.4%. And I think it's probably easy to see that Sarah is going to have an easier time of accomplishing that goal than Janice will. She has a much lower interest rate and more time. The moral of this story is it's better to invest money early, even if it's at a lower interest rate. You will be able to get your money to multiply a lot faster. If you have any questions, make sure you leave them on the next slide for me, and I will try to catch those over the next day or so, and we'll go over any questions you have in class. Make sure once you're finished with this that you begin working on the Go formative that goes for this lesson. Have a great day.